Hello students, this is my recording of Chapter 6, Education. And let's start by looking at a few stylized facts about education in the United States. First point, there are only slight differences in educational attainment between men and women. So today, there isn't much of a difference between men's education on average and women's education. However, there are significant differences in educational attainment between racial and ethnic groups. For example, in the year 2017, only 5.5% of Asians didn't have a high school diploma, as opposed to 7.6% of blacks and 24.7% of Hispanics. So about a quarter of Hispanics in 2017 did not have a high school education, as opposed to only about 5.5% of Asians. Right? In the same year, more than half of Asians had at least a college degree, as compared to 40% of whites, 20% of blacks, and 16% of Hispanics. So what seems to be coming out of this is that if you rank the various racial ethnic groups by education attainment, Asians are right on top, whites, blacks, and then Hispanics, right? Next, education has a significant effect on labor market outcomes. For example, the labor force participation rate increases in education. So the more educated you are, the more likely you are to participate in the labor force. And what does that mean? Who is in the labor force again? Those who are employed and those who are not employed but actively looking for work. That makes up the labor force, correct? And the labor force participation rate is the labor force as a percentage of the civilian non-institutional population, also called the working age population, correct? So the more educated you are, the more likely you are to be in the labor force, right? So it says here that the labor force participation rate of high school dropouts was 59.6%, let's say about 60% in 2017, right? So among high school dropouts in the working age population, about 60% were either working or actively looking for work. But this figure was 85.1% for college graduates. So college graduates are much more likely to be either working or actively looking for work than high school dropouts, right? Now, if you look at the unemployment rate, you will find that the unemployment rate is also much higher for high school dropouts than for college graduates. So the unemployment rate of high school dropouts was 8.4% in 2017, but only 2.3% for college graduates. So college graduates are much less likely to be unemployed compared to high school dropouts. Next, if you look at the average salaries, high school dropouts in 2017 earned an average of $31,000 a year, whereas college graduates earned $81,300 a year on average. All right. Next, education greatly benefits minorities. So there's a special benefit of education for minorities. The unemployment rate of black high school dropouts was 19.4%, as opposed to 8.8% for black high school graduates, and only 3.2% for black college graduates. So black college graduates experienced very little unemployment, 3.2%, as compared to almost 20% for black high school dropouts. Right? If you look at Hispanics, Hispanic high school dropouts earn only $31,000 per year on average, whereas Hispanic college graduates earn $64,000 per year on average. Now you'll observe that the $64,000 for Hispanic college graduates is less than $81,300, which is the average for all ethnic and racial groups together. So Hispanic college graduates earning a little less than, let's say, their peers in the other racial and ethnic groups. There could be a number of reasons for this, but one important reason is the concentration of Hispanics in low-wage areas. Consider our own region, the lower Rio Grande Valley. Wages here have traditionally been lower than in the nation, right? And as we all know, a lot of our local people are reluctant to leave the region. We just live here. We like to live here, correct? And so that sort of depresses our wages, even if we were college graduates, right? So that's part of the story. All right, next we come to this very important notion. This is borrowed from the discipline of finance. It's called present value calculation, right? So let's say we're talking about a sum of money that you're going to receive 1 year from today. So this is a sum of money that you're going to receive. Let's call it $100, right? So let's say that you were going to receive $100 in 1 year's time. correct? This is what you're going to receive in 1 year's time. How much is this money worth today to you? Is it going to be worth $100 today? Well, the answer is no. It's going to be worth less than 100 today. But why? Because you are impatient. Humans are impatient, right? Money coming to us in the future, a dollar coming to us in the future is not going to be treated as a dollar today. We'd value a dollar today more, right? So in other words, what we do is we discount future dollar amounts. We bring it down, in other words, correct? So each one of us in our heads has a personal, we have a personal rate of discount. Think of it as a personal rate of interest. So each one of us has a personal rate of discount. So let's say my personal rate of discount is 5%. So how much is the $100 that I'm going to receive 1 year from now worth to me today? But the answer to that question is the number X, which I can say put into a bank today, paying 5% interest, for this to become $100 in a year's time. Do you understand? So the present value of the $100 is X. And what is X? X is the sum of money that I would need to put into a bank account today, paying 5% interest, 5% being my rate of discount, so that the X grows to $100 in a year's time. Now, how do we do this math? Well, if you know about compound interest, you know quite easily that when you put the X into the bank today, what you get back in a year's time is 1 plus the rate of interest expressed in decimals. And this we want to be $100. So what is X? X can simply be solved as $100 divided by 1 plus 0.05. Is that correct? So that's what this present value calculation is. So what's it says here? Present value of PV is equal to Y, and this Y was like the 100 that we had in our example, correct? And you divide that by 1 plus R. R is our rate of discount, which in our story is 0.05, 5% expressed in decimals, to the power T. And what is T? T is the number of years in the future when you're going to receive this sum Y. Now, in our story right now, T was equal to 1 because you're going to receive the $100 in 1 year's time, right? But if you were going to receive the $100 in 2 years' time, then of course the equation would be like this: X times 1 plus 0.05 squared. This is the formula for compound interest again. And that you would want to be equal to 100. So that would make X equal to 100 divided by 1 plus 0.05 squared. Right? So this is how the future is discounted. Of course, this sum here is less than 100. How do I know that? Because I'm dividing 100 by a number bigger than 1. The denominator here, as you can see here, is bigger than 1. So if you're dividing 100 by a number bigger than 1, you're going to get less than 100 as your answer. Right? So this is what discounting is about. And why do human beings discount the future? Because humans are intrinsically impatient. Right? All right, now here we have a diagram that shows us the income streams of someone who quits after high school and someone who decides to go to college, right? So high school, one usually graduates at age 18. So the individual quits high school. He's going to make so much in wages every year, all the way to age 65. This is the age of retirement, right? So from age 18 onwards, this is age 18 and this is age 65. You make this wage WHS. The HS subscript is high school, right? Now, on the other hand, if you decide to go to college, and you go to college for 4 years, 18 to 22, and these 4 years, your earnings are actually going to be negative H. What is this? Because assuming that you're a full-time student unable to work, right? You're going to be earning nothing, but you're going to have to be paying the cost of college. And the cost of college is $8. So you have negative earnings for these 4 years. Correct? But thereafter, your wage jumps to a level higher than WHS. It jumps to a level equal to WCOL, COL for college. So this is the college, post-college wage. And then from age 22 to age 65, you make that higher wage. So let's ask this individual, what are you going to do? Are you going to go to college or not go to college? So in order to figure that out, the individual would have to compare these two income streams, right? But of course, remember, where is the individual now? The individual is deciding whether or not to go to college. So this is where the individual is. So this is where the individual is located. Just graduated high school, figuring out whether to work immediately or to go to college for 4 years, right? So of course, these income streams have to be discounted to the present. Remember discounting, figuring out the present value? So that's what we're going to do next. So let's consider the present value of deciding to work immediately. So the present value of just being a high school graduate. You're going to take the WHS for each year. So this is WHS at age 18, right? This is WHS at age 19, 20, etc., all the way to age 65. And we're discounting now. The WHS at age 18 itself does not have to be discounted because that is the wage at present. But the wage at 19 has to be discounted by 1 year. So 1 plus R is a rate of discount in decimals, right? To the power of 1, because T is 1. Remember the present value calculation? Present value is equal to Y divided by 1 plus R to the power T, correct? Y being the payoff, right? So if you look at age 19, the payoff is WHS, but the payoff is 1 year in the future, right? Remember, the vantage point of the individual is age 18. That's where the individual is right now, looking out into the future, right? So all present value calculations have to be made vis-a-vis age 18, right? So that's the present value of the earnings at age 19. This is going to be the present value of earnings at age 20, discounted 2 years, right? And on all the way to age 65, 46, to the power 46. Correct? So, by the way, how do I arrive at the number 46? 46 is basically 65 minus 18 plus 1. Now 65 minus 18 is how much? 65 minus 20 is 45. Minus 2 is, 65 minus 20 is 45, right? Hang on. So minus 18 would be 47, but why do we have 46 instead? Because remember, for age 18, there is nothing, right? It's 1 plus R to the power 0 in a sense, right? So if you go all the way to age 65, it won't be 47, it will be 46. 65 minus 18 plus 1, right? That's where the 46 comes from. Now, on the other hand, if the person decides to go to college, what's going to be the present value of the income stream? Well, for the first 4 years, so this is age 18, age 19, age 20, right? Age 21, 4 years of college, right? So this is the discounting of, so these are all negative numbers. Why? Because these are all costs of college. H is the cost of college, right? So the income is the negative income because the individual, instead of earning, is actually paying out money. But thereafter, age 22 onwards, it becomes a positive number. The college wage kicks in, and that goes all the way to age 65. Correct? So when is this person going to go to college? This person is going to choose college if the present value of the college stream is bigger than the present value of the high school stream. In other words, if this is a positive number, then the individual decides to go to college. So let's actually figure this out. Let's do the subtraction, right? So if you do the subtraction, you can do it, it comes out like this. So minus H minus WHS, that will be for age 18, right? And this will be for age 19, minus H minus WHS. Now you can put the minus outside of brackets, and within brackets you have positive numbers, right? And this is at age 20, right? And this is at age 21. And thereafter becomes W college minus W high school, the college wage minus the high school annual wage, etc., all the way to age 65. So this is at age 22. Correct? If the above is positive, the individual will attend college. Now, when is it likely for the above to be positive? Now, where are the positive numbers? The positive numbers actually kick in from here onwards, right? This is a positive number. This is a positive number. And from here onwards, it's all positive numbers. But the first four numbers are negative. That's a negative number. That's a negative number. That's a negative number. And you see this minus sign here? But that's a negative number. So four negative numbers in the beginning and then followed by positive numbers. Correct? Now, one thing it says here, the higher the rate of discount, the smaller the positive numbers. Because you see, you're dividing by the R. So the higher the R, the bigger the denominator, correct? Bigger these denominators. So the smaller the positive numbers. Right? So basically, the higher the rate of discount, the smaller the positive numbers, and the less likely it is for the present value of the college earning stream to be bigger than the present value of the high school earning stream. Correct? So the bigger the rate of discount, the less likely it is for the positive numbers to outweigh the negative numbers. Because each positive number is dragged down by this denominator, 1 plus r to the power, etc., to the power t. So the bigger is r, the bigger the sort of discounting that takes place. Right? The more impatient you are, in other words, the smaller you are going to think of a future wage gain. Right? So the more impatient individuals will be likely to then not go to college and just start work immediately after high school. Why is that? Because for them, in this equation here, the negative numbers will outweigh the positive numbers. Right? Now, the last point on this slide is that the rate of discount is subjective. So different people have different levels of impatience. Right? Now, one can be trained, by the way. One can be trained to become more patient, less impatient. Right? That training can be imparted. But generally, we are born with a certain temperament, right? And so if we don't interfere at all, then people are going to have different, vastly different rates of discount. You have impatient people and patient people, right? Who are the ones more likely to go to college? The impatient or the patient? Those with a higher rate of discount or those with a lower rate of discount? As I've just mentioned, the higher the rate of discount, the less likely it is for the positive numbers to outweigh the negative numbers in this calculation. Correct? So it's the patient, those who have a lower R, a lower rate of discount, who are more likely to go to college. Because for them, the positive numbers that you see here, which begin really at age 22, right? Those positive numbers are more likely then to outweigh the first four negative numbers in this calculation here. All right, the wage schooling locus. Now, most people, labor economists figured out the relationship between earnings and wages has this particular form. Now notice that this is a positively sloped curve. So in other words, an extra year of schooling yields a higher annual earning, right? So in this story here, somebody with just 12 years of schooling earns $20,000 a year. With 13 years of schooling, that's 1 year of college, your earnings go up to $23,000 a year. With 14 years of schooling, which is typically your associate degree, $25,000 a year, etc. Right? With 18 years of schooling, which would be a graduate degree, typically, right? In this example, $30,000 is the annual salary, right? So we see that the wage schooling locus is positively sloped, but it also has a certain curve. And how do you describe this curve? It is concave to the origin, right? So the wage schooling locus is positively sloped, upward sloping, right? The slope of the wage schooling locus indicates the increase in earnings associated with an additional year of schooling, right? And the wage schooling locus is concave, reflecting diminishing returns to schooling, right? So the percentage increase in earnings when you go from, let's say, a bachelor's to a master's degree, well, the percentage increase there is smaller than when you go from, say, high school to an associate degree. Right? High school to an associate degree gives a bigger percentage boost to income than going from 16 years of schooling to 18 years of schooling, right? Which is a bachelor's to a graduate degree. That's why we have this concavity of the wage schooling locus. So what's the marginal rate of return to schooling, or the MRR, marginal rate of return to schooling? The marginal rate of return to schooling is simply the change in wages from a small change in schooling expressed as a percentage of what wage used to be, right? So for example, when you go from 12 to 13, what is the marginal rate of return to schooling from the 13th year of schooling? It's going to be the earnings from 13 years, which is 23,000, minus the earning from 12 years, which is 20,000, expressed as a percentage of the 20,000. So it's 15%. So that's the MRR associated with the 13th year of schooling, right? And what is the MRR associated with the 14th year of schooling? The MRR associated with the 14th year of schooling would be what? What would that be? Wouldn't that be 25,000 minus 23,000, right? Divided by 25,000 divided by 23,000 times 100. And while I don't have a calculator handy to do this, why don't you work it out and convince yourself that that number is smaller than 15%. So in other words, the MRR has dropped from when one goes from 13 years of schooling to 14 years of schooling, right? The MRR from the marginal rate of return to the 14th year of schooling is smaller than the marginal rate of return to schooling from the 13th year of schooling, right? So in other words, if we make a graph like this, years of schooling and the MRR, we have a negatively sloped curve. And why is it negatively sloped again? One of the reasons is the concavity of the wage schooling locus, the fact that you have diminishing returns to schooling, right? An additional year of schooling confers a smaller benefit to you as the years of schooling increase. Now for the schooling decision, right? How many years of schooling is optimal for you, right? And here, basically, one has to make a comparison between two things. One has to make a comparison between your rate of discount, your personal rate of discount, and this depends upon how impatient slash patient you are. R is bigger for when you are more impatient. So you have to compare R to the marginal rate of return to schooling. I'll explain this in a second. So in this diagram here, what's the MRR associated with the 13th year of schooling? 10%. What does this mean? That means that, let's say we have somebody who's just completed 12 years of schooling, just completed high school, and is considering, so the individual has just completed high school and is considering attending a 13th year. She knows that the additional year of schooling will raise her wages by 10%, because that's the MRR associated with the 13th year of schooling. In other words, if her present wage is $100, her wage will rise to $110 with an additional year of schooling, with 13 years of schooling. Right. Now, let's say that her rate of discount is 11%. I'm going to mark it here. Let's say that's her rate of discount. That's the individual's R. Right? So if her rate of discount is 11%, what is going to be the present value of the $110? The $110 she's going to earn after finishing 13 years of schooling, right? So what is that worth to her today when she's just finished high school? She's just completed 12 years of schooling. Well, we know how to discount, right? We go 110 divided by 1 plus the R, in this case, to the power 1. So this is 1 plus R to the power 1. What is R? R is 11% or 0.11. So 1 plus R will be 1.11 to the power 1, which is just 1.11. So 110 divided by 1.11 happens to be 99.1. Now this is less than the 100 she's already earning. So will she consider going for a 13th year of schooling. Because she earns, if she goes for a 13th year of schooling, her earnings, her higher earnings in the future, $110, really boil down to $99 today. But she's already making $100 today. So why would she bother to acquire that 13th year of schooling? She would refuse to go to school for one more year. You follow me? It's just not worth it for her, given her rate of discount, given her level of impatience. Right? So she won't consider it worthwhile to attend a 13th year of schooling. So in other words, last sentence, in other words, an additional year of schooling will not be invested in if the MRR from that additional year is less than the individual's discount rate. Right, now let's consider a situation where the individual's discount rate is 9%. So this is the individual's discount rate. Right? So now the $110 a year from now, how do I get the $110 again? I'm assuming here that upon finishing high school, the person's wage is $100. The marginal rate of return to the 13th year of schooling is 10%. So in other words, if the person goes to school one more year, the resulting wage should be $110. It's 10% bigger than 100, right? So the 110, of course, has to be discounted to the present. And this is how it's going to be discounted, 110 divided by 1.09 in this case. How do I get this again? This is basically 110 divided by 1 plus r to the power 1. And what's the r? 0.09, which is 9% in decimals. If you do this correctly, you get 100.92. So in other words, if you go to school one more year, this person is going to make, in today's money, the present value is going to be 100.92. Now this is more than the 100 the individual is currently making, or capable of making, right upon graduating high school. So since 100.92 is bigger than 100, it will be worthwhile to go for an additional year of schooling in this person's mind. Correct? Because the result is going to be higher earnings, even in present value terms. So she will consider it worthwhile to attend a 13th year of schooling. So basically it follows that the individual will attend an additional year of schooling until the marginal rate of return to schooling equals her rate of discount. Correct? So if the rate of discount is less than the MRR, then the result is go for schooling. Go for one more year of schooling. Correct? Now we also learned in the previous slide that if R is bigger than MRR, then don't go. Don't go for one more year of schooling. So where does the person actually stop? Where does the person actually stop taking one more step forward, where the step is one more year of schooling, where the two are equal? Right? So in other words, if this is the MRR curve, and let's say you have an individual with a rate of discount of R1, right? So how many years of schooling will this person take? This person will stop right here at S1 years of schooling, where the rate of discount is equal to the MRR. Right? On the other hand, somebody who is less impatient, somebody with a smaller rate of discount, that person will find it worthwhile to acquire more schooling, S2. So this is a nice diagram that shows us that the more patient individuals are the ones likely to acquire more schooling. Now this is, if you think about it, this is true all around us. If you look all around us, the impatient people who, let's say, get married young, now that's kind of impatience, isn't it? Right? To, fulfill that part of our desires or whatever it is, quickly, early, young in life, right? Those are the people who are less likely to then acquire more education, right? This is one way of thinking about it, right? So you can see all around us, the people who acquire schooling are the more patient types, right? Now let's say we have workers with different abilities. So you have two guys here, Ace and Bob. Now if you look at them, wage schooling loci. Loci is the plural of locus. Loci is the plural of locus. So if you look at that loci, you find that Bob has a higher wage schooling locus, right? So with the same years of schooling, 12, Bob earns that much more. Now this can be ascribed to Bob's higher ability. So this is due to a difference in inherent ability between the two individuals, because they both have the same level of schooling. So they have the same level of skills, let's say, learned in school. But the higher ability person is yet capable of earning more because of his intrinsic higher ability, something that he was, let's say, born with, right? So if you look at the MRRs that come out of these two loci, this is ACE's MRR curve, right? And this is Bob's MRR curve. And you can see that for every level of schooling, the MRR is higher for Bob than for ACE. What is the MRR again? It's the percentage increase in earnings from an additional year of schooling, right? And that is higher for Bob than for ACE. Why? Because Bob has higher inborn, innate ability, right? Now, if you consider ACE and Bob, and let's say that they both have the same level of impatience, same level of discount, you can see here quite clearly that the higher ability Bob will acquire one more year of schooling than ACE. So this diagram basically tells us that individuals with higher abilities also tend to acquire more schooling. In the previous slide, we learned that the more patient person, the one with the lower discount rate, acquires more schooling. But now we learn that differences in schooling between individuals may also be because of differences in ability and not just differences in the rate of discount, the level of patience. Right? Now, the thing about ability, once you throw in ability in the story, the wage difference between Bob and ACE. Now, Bob gets 12 years of schooling, right? So what is Bob's earnings? Bob's earnings are going to be basically this, the height of this line here. This is Bob's earnings. And what are ACE's earnings? ACE's earning is equal to the height of this line because ACE acquires 11 years of schooling. So what is the difference in their earnings? The difference in their earnings is this amount here. Correct? This is the difference in their earnings. But can we say this? Can we say that if ACE got one more year of schooling like Bob, if ACE went from 11 to 12 years of schooling, that his earnings would increase by that much? Could we say that? No, we may not. Because if ACE acquired an extra year of schooling, his earnings would only go up by this much. There would still be a substantial ability gap. Right? So the moment you throw in ability, it says here, as a result, the wage difference between Bob and ACE does not tell us by how much ACE's earnings would increase if he were to complete high school. Right? Because his increase would not be the currently observed wage difference between Bob, who was a high school graduate, and ACE, who was a dropout. That difference is this entire distance, as you can see, correct? But that is not going to be the gain in ACE's wages if he were to complete high school. No, it wouldn't. If ACE were to complete high school, his wages would only go up by that much. Correct? Next, estimating the rate of return to schooling. So typically in empirical work, labor economists tend to estimate what's called a Mincer earnings equation. So this equation is called a Mincer earnings function or earnings equation, named after a famous labor economist called Jacob Mincer, M-I-N-C-E-R. Right, so this is the Mincer earnings, typical Mincer earnings equation. We have not wages, but log of wages. We convert wages into log, natural logs, and that's our dependent variable. and we regress that against a constant, years of schooling, other control variables such as race, ethnicity, gender, and things like that. Might even be local labor market conditions. And then we have, as part of the regression error term, we have unobserved ability. Now, this is something we can't control for because this is unobserved. This is part of the regression error. Right? Now, how do we interpret the B? Right? The B, of course, is the slope coefficient, right? So the B would be this, for those of us who know some calculus. It's right. What's B? It's dy by dx. What's our y in our story? Our y is this, log wage. And what's our x? Our x is s. So what's dy by dx, which is B, the slope? It's going to be d of log wages divided by d of schooling. And we can rearrange this as follows. We can write this as d log wage divided by d wage times d wage divided by d schooling. Why? Because these two things would sort of cancel out, right? Now, why am I doing this? There's a reason. Bear with me. Now, what is this equal to? For those of us who know how to take derivatives of log functions, again, if you haven't done calculus, don't worry about it. Just hang in there. Well, there's a formula for this, which you would have learned if you've done calculus. The derivative of a log function is simply 1 divided by the wage, right? And then you have this dw by dsi. Now this we can finally write like this, dwi by wi, right? The whole thing divided by dsi, correct? Now, what is dwi by wi? D is a change, right? So this is a change in wages divided by the original wages. Now, if you multiply this by 100, the numerator would be what? The percentage change in wages, right? Now you're dividing this by DSI. In other words, this whole thing here is the percentage change in earnings from an extra year of schooling. So in a Mincer earnings equation, the coefficient of schooling B times 100 can be interpreted as what? The percentage change in wages or earnings from one extra year or one additional year of schooling, right? So this is what labor economists typically estimate to figure out the rate of return to schooling. That's what B times 100 is, the percentage change in wages from an extra year of schooling. Now the problem is that because of unobserved ability, we end up with bias in our estimate of B, right? Because unobserved ability, remember, is part of the error term. So what we have here is positive correlation here. Now we learned this in slide 13, if you remember, right? The individual with higher ability, if you remember, Ace and was it Bob or Joe, whatever. So you have the two individuals, and their MRR curves look like this, if you remember. So this is the MRR of the higher ability person. And this is the MRR of the lower ability person. And if both have the same rate of discount even, we find that they will get different levels of schooling. The higher ability person will get more schooling. So this makes for positive correlation between the error term. So this is part of the regression error, the error term, ERROR. So the error term is positively correlated with one of the regressors' schooling, right? And you may have learned this if you've done econometrics, if you're currently studying econometrics, that kind of correlation leads to our estimate of B, right? When we run this estimate, we get an estimate, it's typically called B hat, the estimate. Well, this is typically going to be bigger than the true B. You follow? So our estimates of the rate of return to schooling will tend to be upward biased because of the fact that the regression error contains unobserved ability, which is positively correlated with years of schooling. So labor economists have spent a lot of time trying to figure out ways around this problem. And here are some solutions to the problem of bias. And one of them is called twin studies, right? So labor economists have gone, typically they've gone to certain fairs. And I don't know if you're aware of this, but in the US you have a number of places where every year twins, identical twins, meet. meet other identical twins. It's like a summer camp for identical twins. So labor economists have gone to these camps and interviewed, pairs of twins. Right? And one question asked was, well, what's your level of schooling? And sometimes the two brothers or two sisters or brother and sister don't have the same level of schooling, right? So in other words, you have so this is this individual one, that's one of the twins of a pair of twins, right? And this is the other guy, the other person, two. So you have a wage equation for the first sibling, twin sibling, and this is the wage equation for the second twin sibling, right? And let's do a subtraction. If we do a subtraction like this, one thing you notice here is that you have this unobserved ability for both, right? But the fact that they are identical twins means that any genetically inherited ability would be the same. Do you follow me? Now, this is true for identical twins, right? So this is a reasonable assumption that can be made. So this is the same. These are identical because they're twins. So once you do the subtraction, basically you can subtract these guys away. They would disappear once you do a subtraction. So a subtraction like this would give us B, the difference in schooling between the two individuals, the difference in other attributes, right? Gender, etc. Of course, there'd be no difference in race, ethnicity. They're siblings after all, but there could be different genders, right? So that difference could be picked up, but they could be living in different labor markets, different cities, and that could be picked up here, right? But one thing that you'll observe is that unobserved ability has been differenced away, right? It's no longer part of the equation. And remember, that's the presence of unobserved ability was the problem. That gave us the upward bias. But now with that missing, once we estimate this equation, we have no trouble. And the estimate of beta that we get, the beta hat that we get, will be unbiased. So this is one way of getting rid of the problem of bias, by going to this data of twins, right? Another way of doing this is called instrumental variables estimation. Again, something that you may learn in an econometrics course, right, here at the university. But let me give you some intuition here. What's an instrumental variable? An instrumental variable is an exogenous variable. Exogenous basically means completely random, unrelated to the equation, unrelated to the individual. It's not something the individual chooses. It's just something random that happens. So it's an exogenous variable, which, while absent from the earnings equation, so it's not part of the earnings equation, it's not part of the right-hand side of the earnings equation, is correlated with years of schooling. So it's some random variable that affects schooling, right? But it doesn't itself directly affect earnings, right? So in other words, an instrument is a variable that affects earnings only through schooling, right? Example of a good instrumental variable might be the quarter of birth. Remember, the year is divided into 4 quarters, right? So which quarter were you born in? The first quarter, which is January, so 12 divided by 3. So January, February, March, April, that'd be the first quarter. So which quarter were you born in? Now that may be a good instrument. Why is that? Because it says here, children born late in the year, that is after August 31st, right? Since they will not be 6 years old compared to people born earlier in the year, will not be allowed to join free public school. So when they join public school, they would be basically a year older than their classmates. You know this, correct? So the fact that if you're born late in the year, you're going to be older than your classmates, means that you will turn 16 earlier than your classmates. Now, what's so important about age 16? Well, in the US, by law, you have to go to school until you're 16. After that, you may legally drop out. Correct? So in other words, the student born later in the year is more likely to drop out at age 16 with one less year of schooling than people who drop out who are born earlier in the year. You see my point? Because the children who are born in the last quarter of the year, for instance, would be older than their classmates, so they will turn 16 earlier than their classmates. Right? So when they turn 16, they will on average have one less year of schooling than others. So when they drop out, or if they drop out, they would drop out with one less year of schooling. correct? So this would make quarter of birth a pretty good instrument for years of schooling. This is not something that's at all related to ability, etc. This is completely random when you were born. There's no, as far as I know, relationship between IQ or ability and quarter of birth. You follow me? I don't think that smarter people are born early in the year or anything like that. So this is completely exogenous, right? And this results in some variation in years of schooling. So we can use this as an instrument, right? So it says here, their additional log earnings. Whose additional log earnings? Those who were born earlier in the year, because they would have one more year of schooling, correct? Roughly. So if you're born early in the year, you tend to be younger than those born later in the year, right? So you would, when you're at age 16, you would have more schooling, one more year of schooling, roughly, than those born in the fourth quarter, right? So the additional log earnings, the difference in log earnings between someone born early in the year and someone born late in the year, the difference in log earnings would be entirely due to the difference in years of schooling and nothing to do with ability, right? So this, if computed properly, will give us an unbiased estimate of the return to an additional year of schooling. Unbiased, why? Because the additional schooling in this case has nothing to do with ability. It is only to do with the quarter of birth in which the individual was born, correct? Which is a completely random event. Now here we have a natural experiment. In 1973, the Indonesian government, country of Indonesia, Asia, launched a massive school construction program. This raised the school attainment of those who were 2 to 6 years old in 1974 and who lived in these high school construction areas. Right? So if you lived in an area where there was a lot of school construction going on, and so you might have a school in your neighborhood, in a month's time because the government's built one, right? This would mean that you're more likely to go to school because it's close by. Correct? So this increase in schooling was not due to differences in unobserved ability. It was simply because the government, built a school in your neighborhood. Correct? So again, this is something entirely random, nothing to do with the individual's ability. Hence, the resulting change in log earnings would yield unbiased estimates of the rate of return to schooling. Why? Because school construction has nothing to do with the individual's ability, unobserved ability. So by this natural experiment, an additional year of schooling raised earnings by 27%. So the B was 0.27. Remember, B times 100 is the percent change in earnings from an extra year of schooling, right? So B times 100 is the 27%. Right. So this is another way of getting at the true B, the true rate of return to schooling. So you can use a natural experiment, for instance, like this, right? Next, let's consider the issue of school quality, the school quality matter, right? An extra year of schooling may not be the same for every school, right? An extra year of schooling might confer higher earnings if it is a higher quality school, right? Now here in this graph, we see that the rate of return to schooling tends to be lower in states in which there is a higher pupil-teacher ratio. So in other words, the classes are bigger. A bigger classroom is a sign of a low-quality schooling because the teacher can now not give individual attention to every student in the class, correct? So the level of individual attention drops off the larger the class size. So in states in which class sizes are bigger, tend to have a lower rate of return to schooling. Or conversely, the rate of return to schooling appears higher, right? Appears higher in US states with lower pupil-teacher ratios, higher school quality. Right? So this is evidence of school quality mattering, right? Additional evidence, you have some evidence from the country of Israel, and there is a negative relationship between class sizes and the test scores of 4th and 5th graders. So again, this is indicative that if you go to a small school with small classrooms, small class sizes, you generally tend to get a better quality of schooling, and your test scores are hence higher, right? And then there's another example. It's called the Tennessee experiment. And what happened here was kindergarten students and teachers were randomly assigned So this was an actual experiment, not a natural experiment, but a deliberate scientific experiment. Students and teachers were randomly assigned to either large classes or small ones. Correct? And students assigned to small classes scored higher on achievement tests and were also likelier to go to college years later. Right? So this is the way experiments are conducted in the sciences. You have a group upon which you have a treatment group and a control group, right? So you have a treatment group and a control group. So, for instance, when pharmaceutical companies were testing the efficacy of the COVID-19 vaccines, they basically divided people into two groups, experiment subjects, that is. You had a treatment group, and these are the guys who got the vaccine, and the control group got simply plain water, a placebo, right? And then they looked at their levels of immunity to COVID. This is how medical experiments are done. So the Tennessee experiment was something like this, right? The treatment group would be those who were randomly assigned to small classrooms, and the control group would be those who were assigned to your regular big classroom. And this tells us that the treatment group, those assigned to small classrooms, scored higher on achievement tests and were more likely to go to college years later. Right? So this is again something that strongly suggests that school quality matters, right? Next, we come to the notion of schooling as a signal. Up to now, if you think about the wage schooling locus, right? The wage schooling locus. A wage here, here's a schooling here. So why does wages go up with schooling? Well, the idea here is that with more schooling, you get more skills. So what's behind all this is the notion that schooling contributes to what's called human capital. So that's the traditional idea, that more schooling means more human capital, hence higher earnings. But there is a completely alternative view, a competing view, and that is that schooling provides no human capital. It's a pure signal. This is the view that schooling doesn't contribute to human capital. It merely signals innate ability. So it's simply a signal of your innate IQ. This is unobserved ability, which is not easy for the employer to gauge. You can't catch this in an interview, for instance. Correct? So what the company does, the employer does, it uses schooling as a kind of a signal of innate ability. So schooling has no value in itself. All it does is provide a signal. So if you went to college, there's a good chance that you are a high ability individual. And so the employer is able to sort these anonymous, faceless, people into two groups, high ability and low ability. Now this is an advantage for firms because firms can now pay the high ability workers more and the low ability workers less. And also assign them to the right jobs. The high ability people go to jobs that require higher ability. Correct? So this is an advantage. The ability to sort between workers of different abilities. And schooling enables firms to do this kind of sorting. All right? Now it says here, to be a good signal, in order for schooling to allow employers to sort, as I described, sort workers into these two groups, high ability and low ability. In order for schooling to be a good signal of ability, schooling must be more expensive for the less able. It must be more expensive for the less able. Otherwise, what will happen is that the less able will also go and acquire more schooling. Right? And then the employer will think that this person is a high ability person when in actual fact he's a low ability person. So schooling will not have served the purpose of enabling the employer to sort the workers into the two groups. Right? So you want schooling to be more expensive for the less able so that they don't acquire the signal to the same extent as do the able. Right? Now it says here, say there are two types of workers, a low productivity type and a high productivity type. Now this is from birth. This is innate, right? But productivity isn't immediately observed by employers. So you have in the population a proportion Q, right, which is low productivity. And the present value of lifetime productivity is $200,000. So these workers can produce $200,000 worth of goods over their lifetime in present value terms. The high productivity individual can produce $300,000 worth of goods over his working life. and there are 1 minus Q proportion of them in the population. For instance, Q might be 30% or 0.3, and this might then be 0.7, for example. So how much should an employer offer to pay a worker given that her type isn't immediately observable? Right? The company, the firm cannot determine what type of worker is standing before it. Correct? So what kind of wage should be offered? Well, one would be what's called a pooling equilibrium. So what the firm may do is offer everyone, high productivity and low productivity, a weighted average of 200,000 and 300,000. And what is that weighted average? The weights are going to be these proportions in the population, right? So this would be kind of like the expected lifetime productivity. What's the expected lifetime productivity? 200,000 multiplied by Q, which is the probability that the person standing in front of you, the company, is a low productivity worker, right? Plus 300,000 multiplied by 1 minus Q, 1 minus Q being the probability that the individual standing before you, the company, the employer, is a high productivity individual. So this is like the expected productivity. So you pay everyone this, high or low. Now this of course means that the low productivity workers are getting paid more than $200,000 because this is a weighted sum. It's a number between 200,000 and 300,000. So they'll be real happy. But the high productivity workers will be unhappy because they'll be paid less than what they're worth. Right? Now, besides this, the company will be unhappy because the company will now probably mismatch workers. Right? A low productivity worker might be assigned to a job that requires high skills, high ability. And that low ability worker might bungle the job, etc. Right? So who are unhappy in the story? The high productivity worker who is now being underpaid and the company itself. Who's happy? The low productivity worker is happy with this type of pooling equilibrium. So this is not ideal. You have two unhappy parties, one happy party. Right? So what would be ideal instead is what's called a separating equilibrium. So instead of a pooling equilibrium, which I've just described, we want a separating equilibrium. Now to get a separating equilibrium, schooling has to be more expensive for the low ability individuals. So they don't acquire as much of schooling as high ability individuals. Only then can schooling be a good signal, as we've just discussed. Right? So let's say the cost of acquiring a year of schooling is $20,000 per year for the high ability, high productivity workers, and $25,001 for low productivity workers. So it's more expensive for them to go to college. Now, how do you justify that? Right? Is college more expensive for low ability individuals? Well, not in terms of tuition. High ability, low ability people pay the same tuition, buy the same books. But you might think of the low ability person having a harder time studying. It's more agonizing to study. For the low ability individual, right? So the studying is kind of more grueling, more effortful for the low ability individual. And if you think of this effort in dollar terms, right? If you monetize the discomfort from studying, we might arrive at this higher annual cost of college. Correct? Now, what firms must do here is firms must choose a level of minimum schooling that separates the two groups of workers. Let this level of schooling be Y over bar. It must be chosen such that the employers have to choose Y. This is the cutoff. Those who have more schooling than this are high ability. Those who have less schooling than this are low ability. That's how Y should be. Y over bar should be. Right? So it must be chosen such that 200,000, which is the productivity or wages of a low productivity individual, right? This should be bigger than 300,000, which is the wages of a high ability person, or should be the wages of a high ability person, right? Minus the cost of a year of schooling times Y bar, the number of years of schooling that make up the cutoff. So what does this tell us? That means if you're a low ability person, you're better off not going to college, because if you go to college, yes, the company will think you're a high ability person. will be fooled, the company will be fooled by you to pay you 300,000. But when you subtract from that the cost of acquiring the signal, you're actually worse off than if you did not acquire the signal. So you would not acquire the signal in that case. Right? So if this is the story, then the low ability individual will not acquire the signal, will not acquire Y over bar years of schooling, because it wouldn't be worth it. Correct? On the other hand, the Y bar should be chosen in such a way that the high ability person finds it worthwhile to acquire it. So in other words, the high ability wage minus the cost of acquiring the signal should be bigger than the wage of a low ability person. So this would incentivize the high ability person to acquire the signal. Right? Now this condition here, the first one, if you do the math correctly, it basically boils down to that Y bar is bigger than 3.99. And this condition, the lower one, can be boils down to that Y bar is less than 5. So in other words, if a firm wishes to hire a high productivity worker and sets a minimum schooling requirement of between 3.99 and 5 years, it would be successful. It would be successful in hiring only high productivity workers. So this is a way for the firm, the employer, to sort the workers into the two groups by setting a minimum schooling requirement. To get this job, you have to have between 3.99 and 5 years of schooling. Correct? Now we know that because of this condition here, low ability individuals will not acquire the signal. They won't find it worthwhile to do so because it's more expensive for them to acquire schooling in terms of the discomfort from studying, etc. Right? So this is how a separating equilibrium might be brought about. The GED is a signal. Now, it turns out that some states have a higher GED. You know what the GED is, right? It's like the alternative to traditional high school. If you, let's say, drop out of high school and you want to get high school credentials later on in life, you can take the GED exam, right? Now, some states have a higher GED passing rate than others, right? That is, a certain low score may be considered failing in some states and passing in others. A study has shown that passing with a low score raises earnings over failing with the same low score. So you have the same low score, but that low score is considered a passing score in some states, failing score in others, right? In the states where the score is considered a passing score, well, you find that the individual's wages get boosted by more than when the individual fails the test in the other state. So this, in a sense, means that the labor market treats GED as a bit of a signal of innate ability, right? Because, you have this person with the same score, so the knowledge base of the individual is the same, but one individual happens to live in a state where it's easier to pass, the GED, right? The passing score is lower, so passes and gets a bigger boost in income than the individual with the same score in the other state where the score is a failing score. So what does this mean? This means that the individual has the same score, so same knowledge level, same skills, but the individual gets a higher wage in some states and lower wage in others. So in other words, the GED is being viewed as a signal here. There is no human capital element to content to the GED, it seems. The labor market considers it a pure signal, right? So this is an indication of that. The social value of schooling is a signal. It says that even if schooling has pure signaling value and doesn't contribute to human capital, it would continue to have a positive social rate of return because without it, there would be mismatches between workers and jobs. Right? So basically what's being said here is that even if schooling gave us no knowledge at all, it would still be worthwhile to have schools and universities and have the government subsidize these. Why? Because without schools and colleges, it would be impossible for businesses to sort individuals into these two groups, high ability, low ability. And if firms are unable to do this, then it can lead to lots of botched work because low ability individuals might be assigned to jobs that require high ability, right? And they would mess up the work, costing the firm millions in profits, etc., right? So the argument here is that even if schooling provides no real skills, and the only value of schooling is a signaling value, even then it would be worthwhile for the government to pay for public schooling and to subsidize college education because of the social value of schooling as a signal, right? And that is the end of my lecture.